on the air? Yes. Yes, we'll go. Hello, people in video land. Cool. So today, what are we going to talk about today? There's nothing terribly exciting. Hopefully, you've all submitted your assignments by now. They'll be having the same late marking as previously, which I can't remember what it was. 5% per day for the rest off the maximum mark required for the rest of the week, and then submissions after the end of this week will not be accepted. So you can submit late, but yeah, your maximum mark will be reduced. There's anything else in the way of news that we need to talk about I can think of. I just added, somebody was asking me about the videos. I added links here because they were hidden somewhere in the blog. So if you want to, there are 3, you can get them off YouTube or UNSW TV or iTunes U. Somebody said, actually noticed here, we don't have anything before week 3. Is there videos before week 3, or are they?
There are.
Mr. Video Man?
UNSW TV
yep.
is in beta, to put it lightly.
Right.
So we're going to have a chat with them to see what happened to our old videos.
Okay. So for those people in video land who probably can't hear Morgan, we're going to talk to UNSW TV and see what happened to our old videos, because they seem to have disappeared. Anyway, so there should be videos going from week 1, but weeks 1 and 2 seem to be missing at the moment. So so you get from week 3 onwards at the moment. Hopefully we'll be able to get back those old videos. Yeah, so there's the UNSW TV. Oh, sorry, that's the YouTube channel. Same things here on UNSW TV. And if you're an iTunes user, you can go to iTunes U and launch iTunes. And I couldn't find a direct link here, so you have to go to Engineering and Design. Programming for Designers is down here, and there they all are. So in a way you could download and stick on your iPod or your whatever, I'm presuming. Your iPad if you're that way inclined. So yes, they're in a variety of forms. Still nothing before week 3 though, which is weird. Cool. So what I wanted to do today, got bored with breakouts. I'm going to get another game, and I haven't really thought of a game wrapping for what we're going to do today, but I'll show you a little interactive thing. So what I really want to introduce is the idea of variable length arrays. We talked previously about how there are 2 kinds of arrays, fixed and, actually let me put up the slide. Talked previously about how there are 2 kinds of arrays. That's nothing to do with it. Oh, never mind. Fixed length arrays and variable length arrays, and so far we've looked at fixed length arrays. Today we're going to look at variable length arrays, but before we get there, I'm going to talk a little bit about how we can do stuff reading the mouse, which is why this is the first slide here. We've looked at already how to read a mouse position. So what am I going to do? Okay, how to read a mouse position using, well, not the mouse position, but how to tell when the user clicks on something using using on mouse down events and colliders. And so we had objects with colliders on them, and then when we clicked on them, we generated a mouse down or mouse up event, and so we could tell when an object was clicked on. But sometimes we just want to know where the mouse is in the screen, regardless of whether the user is clicking or not. And we don't really want to particularly be working out whether or not they're clicking on a particular thing. We just want to know where on the screen they're clicking or something like that. So actually we'll start with the slides, and then I'll show you where it's going to go to. So there's a on the input class, which we've already used to get key events and other things, there is a variable called mouse position. And that variable is obviously read-only, so you can't write to it, unfortunately, and move the mouse. But if you read that variable, it'll tell you where the mouse is at the moment. So it gives you a vector 3, which is kind of interesting because the mouse is only an XY position on the screen. So you only have 2 dimensions for the mouse, but it actually gives you back a vector 3. Normally the third part of the Z part of the vector is 0. So normally we have so we get three parts, X, Y, and Z. X is the horizontal position on the screen in pixels. Y is the vertical position on the screen in pixels. And Z is usually 0. 0, 0, 0 is the bottom left corner of the screen, which for some stupid reason is different from the GUI, where 0, 0, 0 is the top left corner of the screen. I have no idea why they did this. It is quite annoying. So there are some instances where you want to do this and you have to switch them around. That is frustrating. But you won't have to deal with that, hopefully. So this gives you, depending on the size of your screen, this will give you a number. So X and Y will both be integers. So they'll be, so this will be 0, 0, 0. And then if we come across here in your usual screen, this will probably be 1023, because there are 1024 pixels across, numbered from 0 to 1023. And if you go up, it probably is 0 to 767 or something like that, depending on how big your screen is. If you have a bigger, higher resolution screen, the numbers will vary. Now that's all very well, but it doesn't really give you a position in your world, right? Your world uses a completely different coordinate system to this. And so we need to be able to convert between this position on the screen to a position that the user is pointing at in the world. Now there's a difficulty there because we've only got a 2D screen, but we've got a 3D world. So we need to have some way of working out where is the user pointing, not just in the 2D space, but are they pointing at this depth or this depth or this depth? And depending on how deep they're pointing, it'll change what they're pointing at. So, but anyway, this gives us an access to the mouse position, which is useful sometimes. So the mouse position, like I said, is in screen coordinates, which don't directly correspond to a point in the world. But in order to translate them into the world, we have, or how we translate them into a position in the world depends on where the camera is. Obviously, the same point in the screen will reflect a different point in the world depending on how we move the camera. So there are two methods to convert between screen and world coordinates. And naturally, because the camera is the thing that makes the difference, these are on the camera class. But you have to have a particular instance of the camera in order to, a particular camera object. So you can't just call it as camera, capital C camera, because that's the class. You have to find a particular camera. Usually you pick the main camera in your scene as the way of doing that. So if we'll get onto that in a second. Oh, I'm going to go back. Okay, we'll go this way. I'll get back to using the methods. Let's talk a little bit about the theory. So I said earlier that this Z coordinate is usually 0. But what you can do, and when you read input.mouse position, you'll get this Z value as 0. But what you can do is set this Z value to a different number, and that will mean how deep into the screen do you want to go. So when we're converting between a mouse position and a screen position, a screen position and a world position, we'll add a Z coordinate to our mouse position to say how deep do we want the mouse to look into the world. So I'll show you what that looks like in a diagram rather than wave my hands around. So here we have, okay, let me break that down into steps. Here we have a camera pointing at the world, right? And so we're looking at it side on, so this is all 3D space, but we're imagining, but here's our camera looking out to the right. We have in the world some sort of screen plane. This is if you imagine if we had like the film of our camera there, then everything behind gets projected onto that plane. Now if this is an orthographic camera, so a normal perspective camera, the further away you get, the smaller things get, right? So a thing at this distance out here will fill the whole screen. It has to be this big in order to fill the whole screen, whereas the thing right up close has to only be this big to fill the whole screen. So a perspective camera will automatically do that for you. If you have an orthographic camera, I didn't draw a diagram for this, but an orthographic camera just looks out straight into the world. So if we have our camera there, then an orthographic camera just does that. And anything, if the screen was there, anything that's here or here or here, they'll all come out to be the same size, right? because the orthographic camera doesn't do any perspective, which is the main difference between, well, it's the only difference between the two. Anyway, but we're dealing with a perspective camera at the moment, so we've got some idea that the screen is at some point in space. Now, it doesn't really matter where we imagine that screen to be. What matters is that if we have a point on the screen there, we need to find some point in space that it refers to. So what we're going to do is say, we're interested in pretending that this point is at a certain depth from the camera. And so we measure that depth from, this is the center of the camera, measure that depth out to here. And now this is the depth plane where we're going to try to find a corresponding point in the world. So then what we do is we cast a ray from the camera through the point to the depth plane, and this will be the point in the world that we refer to. So when we convert, we can pick that depth plane to be at any depth we want, and screen to world point will give us a point on that depth plane. And the nice thing is this works no matter which way the camera is angled. So as long as we specify a distance for that depth plane to be away from the camera, the screen to world point will automatically find a world point on that plane. So an example of how we use this then, we have to get a camera. In this case, the main camera is usually camera.main, or is always camera.main. So you can have several cameras in your scene and turn them on and off to flick between them if you want. But the main camera so the camera that's being used to make the current scene will always be camera.main. So usually when you've only got a one camera game, camera.main is the camera. If you're switching between cameras, then camera.main will automatically switch its value from one camera to another. So we have a camera. We have then a pos variable, which we start out by getting the mouse position as this variable. Now initially that mouse position has a z coordinate of 0, but we're going to set that z coordinate to say 10, right? Which sets that depth plane to be 10 units away from the camera, in front of the camera. And then we can call screen to world point on cam in order to convert this mouse position to a position in the world. Now depending on where our camera is facing, that point will be in different places, but it'll always be at that XY position but deeper into the screen. So it'll be the point, this will give you the point in space at that depth, which would be rendered at the mouse position. So according to the camera, the point in space where the mouse is. We can also do the reverse, do world to screen point. If we give the coordinates of an object in the world to screen point will tell us where it is on the screen and how far in front of the camera it is. And so world to screen point gives us an XY position in pixels, tells us where it is on the screen, and a Z position in depth, which tells us how far in front of the camera it is. So this is handy. The nice thing is it gives us the ability to pick points in the world using the mouse. So I'll show you what we're going to do with that. Oops, we can quit that. Thank you. So what I'm going to do is I've made a little empty scene here, and I'm going to I have a target prefab, which is just a little green sphere, and what I'm going to do is create a bunch of them where we click the mouse. So I'm going to create an empty object called targets, which is going to hold the targets and which is going to hold our script for creating them. And I'm going to create a script here called create targets and edit that. Edit it. Thank you. Okay. And we'll just create targets wherever the user clicks the mouse. Okay. So what we're going to do is now there's another method on input. If you look, get mouse down, it actually requires a parameter as well. It requires tell it which button, so 0, 1 or 2 for the left button, the right button and the middle button, I think. We'll just, 0 is the usual button for the left button on the mouse. So that says if the user has just pressed the left mouse button, I'm assuming that I've got that right, but we can check that in a second. Put target at the current mouse position. Okay, so we need a target prefab, so var target prefab dash game object, which we'll fill in the editor. And so now we need the position. So we say var pos position is the mouse position. So we get the mouse position. There's the mouse position. Now, how deep do we want to project this into space? If we, one thing, if we just do now pos equals actually camera dot main. So main. Let's do that. Let's get that into a camera. Cam. Okay, there we go. So we have the camera. So if we say pos equals cam dot screen to world point pos. So actually, let me give them more meaningful names than that. Screen pos, and let's call this one world pos. There we go, to make it clear that they're in different spaces. So we've converted the screen position into a world position now. Now, I'm going to need to draw this on the board. The problem with this code at the moment is that the depth that we've, because the z coordinate of a mouse position is normally z, is normally 0. We're asking to project it at point 0. So if that's the camera's view, right, then here's the screen. Depth 0 from the camera is here. So this point is being projected to the depth 0. And so it's going to come out as exactly that point. And no matter what point we have, if we project a point to 0 in a perspective camera, it's always going to come out to exactly the same point, which is a bit mysterious the first time you do it, but it makes sense, right? Because you're projecting to exactly the point where everything meets, and so everything is every point is exactly the same at depth 0. What we want to do is project it out here somewhere into the actual world. So we need to set what's this depth that we're going to project at. So we need to set a depth. Let's say the appropriate depth that we want to do is we want to, if our target, if we look here, look at this from the right hand side, if our targets are there and our camera is there, right, you can see that very well. So if our target, this is where our target container is, this is where our camera is, the natural depth is to put everything in this same plane as this target container. In which case, it's easy to do that. The way to do that is to calculate the distance from here to here, and that'll be the depth that we're projecting everything at. So, and we can calculate that simply enough by saying screen pos.z equals, so the distance from the camera to the current object is the camera.transform.position minus transform.position, really should be a shorthand for doing this, dot magnitude. All right, so we've taken the vector from one to the other and we've got the magnitude of that vector. That should now give us a point which is in the same plane as the container object, I'm assuming. I haven't really thought that through, so maybe, yeah, I think that'll do. So that gives us a point to place the object. Now we need to make an object, so var target equals instantiate target prefab. and target dot position, target dot transform dot position equals world pos. Now let's see whether I got that right. What does Unity say? There's an error. Please rename. Oh, okay, I've got another script with the same name. Let me make this, let's call it something else. Make targets. There we go. Okay, get mouse down is not a member. What did I mean? Help. Scripting manual. Input. I should look at the docs. Get mouse button down. Okay. Get mouse button down. Oh, yes, because I just renamed the file. Let's close that. Shut up. Close that. Go away. Oh, now I've got it confused. Oh dear. Anyway, just tried to save a file which didn't exist anymore, and I've confused everybody. Right. Just talk amongst yourselves for a moment. Dum-de-dum-dum-dum. Kill. Die. Right. Ignore. Let's try that again. Okay, there we go. Over here. Thank you. Okay, get mouse button down. This is make target, so we can save that. Unknown transform. Where have I got the word transform? Transform. Transform. What's wrong? Transform. That's better. Any more bugs? Okay, nothing. Good. So now if we press play. Alright, okay. Let me change that background color, skybox color to white so that you can see better. Play. And it's not working, and that would be because why? Because I didn't put the actual script on an object. So we put the script there, and we set the prefab to there. Yes? No? Yes, good. And yeah, there we go. We've got objects in the world. They're weird looking black blobs. The reason they're weird looking black blobs is they haven't got a light in the world. So let's just add a light, directional light. Let's put that light on the camera and set its position to 0. 0. Yeah. There we go. We're clicking and we're making blobs in the world. Woohoo! See, so that's pretty cool. And if you look in the scene, all of those blobs are being made here in the same plane, like where I said they were being made. So they're all being made at depth, whatever that depth is away from the camera. Which is good, which is what we wanted. Okay, so in fact, let's also, while we're here, let's set the target dot transform dot parent equal to transform, so that they're all grouped together under the same thing. So now if we do that, they should all be grouped together in here under targets. Yes, that's better. Okay, cool. Okay, let's make something that moves between targets. So let's make a player. We'll grab, create a capsule. We'll call that capsule player. And I'll just put this color on it to make it red, and I'll make it about smaller than that. And put it at 0, 0, 0, which is where I want it. And there it is in the world. Cool. Okay, now we want to make something that follows the target. So what I want to do eventually is have this player move through all the targets that I draw in sequence. So if I put 5 targets like that, it'll visit this one first, then that one, then that one, then that one, then that one. And we're going to use an array to keep track of the targets that we're pointing at. So let's first of all make a simple script. Use script, create JavaScript. We want to make a let's call it move to target. So we have a target that we're moving towards, and that's going to be a game object. And we're going to have, we'll also have a speed at which we move. Speed, and we'll pick about 3 as being a good starting value for the speed. And we do the usual business. Actually, this is nice. Now that we've done, since we did the other week about how to transform coordinates, that means there's a nice trick we can do. If we do transform, inverse transform point target dot position, target dot transform dot position, that automatically takes the position of the target and converts it into our local coordinate space, which tells us basically which direction the target is away from us, away from the way we're currently facing, which is handy. The other handy thing, let's also put in here, so then we can just take that. So that basically automatically gives us a vector in our local coordinate space pointing towards our target. So that if we currently said transform.translate v, that would move us straight towards that location, because that location is a bearing, is a vector where I am 0, 0, 0. You're my target. You're at whatever position in the world you're at. If I move in that, if translate takes a local coordinate, a vector in local coordinates. So if I move by v, I move straight to your position. Now we don't want to move straight to your position. We want to move. We want to normalize that, and then multiply it by speed and multiply it by delta time, so that I move. Time. Delta time, so I move it at a certain fixed speed towards you. So that there's a two-line tracking code, which is really nice. So once we know how to use, I mean, originally this would have been several more lines of vector calculations, but once we know sort of how to use the API of Unity really well, we can start making things shorter by using these built-in functions quite quickly. So if we put that on, I've got an error. That's because they can't spell, these stupid American people. No offense to Americans. Some of my best friends are Americans, but they still can't spell. There we go. It's with a Z. So now if we attach that to the player, move to target. And let's, for the time being, put a target in the world somewhere over our, let's not do that. Let's do this. Something like that. Let's drop a target into the world. Let's give it position 0, not position 0, 0, 0. Let's put it there and over there. Is that on the screen? Yes, it is. Cool. So now hopefully, whoops, I forgot to set that. Player. Close. Move to target. So we need to then set that as the target. So this is stuff that we did ages ago. Where have I gone? Oh, that's one of the more annoying features of Unity. Is that when you click on one thing to drag it into somewhere, it changes view. There we go. Okay, so now this should move towards that. And there it goes, and it moves to that, and when it gets there, it stops. Lovely. We've seen that. We've done things like that since week 1, so you shouldn't really be impressed. It's a little bit annoying that it faces the wrong way. So what we can also do, there's another Unity it could do a lot of calculating to work out which way to turn the object in order to face towards it. But there's a really nice shorthand in another built-in thing. In transform, there's a method called lookAt, which just takes another transform or a point in the world. Whoops. It either takes a vector 3, which is a point in the world, or it can just take another transform. So that says rotate the current object so that it's facing the target object, which is nice. So now if we run our code again, okay, there's a bit of a problem. When it rotates it, it's come going in sideways, right? That's not what we wanted. Turn this off. Turn off, quit. The reason that it goes in sideways is look at it's really convenient, but always look so that the forwards coordinate of the object looks towards something. And the problem we have here is that when we look at our capsule, it's not the forwards vector that we want. The forwards vector is the blue one, which is currently pointing into the screen. So that's coming out the side of the capsule. So when we make the capsule look at the sphere, that blue arrow points towards the sphere. What we want is to have the green arrow, which is the up vector, point towards the sphere. There is no way to look at which vector to make look which one of the coordinates you want to look at the thing with, which is annoying. So, but what we can do is we can change the coordinate space of our object so that our coordinates are rotated around. And there's a neat little trick that we can do to do that. What we do is create an empty object, put it there, then we'll rotate this empty object. So rotate around the x-axis. So now the y-axis of the empty object is pointing out of the screen, and the x-axis of the empty object is pointing down. Now we put our player inside that empty object, so that our player is now a child of that. And so if we rotate that empty object, we also rotate the player. Now all we have to do is move the player around inside there. So if we rotate the player around, right, there we go. So now the green y-axis of the player is lined up with the blue forwards axis of the joint that it's inside, right? So anytime we move that joint, we'll also move the player inside. So what we'll do is if we take this script off here and instead add that script to the joint. Now what the script is going to do is make this blue axis of the joint point towards the target. When we turn the joint, we're going to turn the player capsule inside the joint at the same time. And so the green, because the player capsule is rotated around, the green axis, the up axis of the player is going to point towards the target. So it's a neat little trick. It's a way of saying the body has one set of axes, but we actually want to rotate those axes around. Rather than try to change the body itself, we just put it inside a joint which has its axes pointing in a different direction, and then put the scripts on the joint rather than on the body. So if we run that now, let me set that to set that script. Make sure that I've removed the script from here. Yep. Now, hey, there it goes, and so it moves in the right direction. So that's a handy little way of we're using the look at method, so so it's making the forwards vector move, but instead of but it's running on the joint rather than on the body. So let's rename these things now to let's actually call that player, because that's now really the player object. This is just the player's body, so we'll call that player body. So now we have what we wanted. We have the starting point for what we wanted. We have an object tracking towards a target. So let's remove that target from the world now. Now what happens if we run it now? So if we run it now, you'll see there's a message. Well, you'll see there's a message down the bottom of the screen that we've crashed because there's no target assigned. Well, so this is what we want as our starting position, so we need to do something when there is no target. So let's go back to our move to target. If there's no target, then the value of the target variable is going to be null. Remember we've talked before about how if you have an object variable that has no value in it, or if you haven't assigned a value to it yet, it's going to be null. So we can check for that. We can say if target equals null, or actually if target equals null, then there's nothing for us to do. And if there's nothing to do, then we just return. We've seen return before in functions. In this case, previously when we returned a value, we'd say return 5 or return whatever the value we wanted to return. Here our function doesn't, the update function doesn't have a return value, so we can just say return on its own, which means quit the function, go back to whatever you were doing. So that's a nice way of checking. If we have no target, then there's nothing to do, so we'll just finish what we're doing and go and move on. So now if we run our code, it happily sits there, doesn't give us an error, whoops, and it just sits there and does nothing as long as it has no target. Now if we click on the screen, we can make targets, but we haven't actually assigned them yet to the object, so for it to know that it's meant to be tracking them. So that's the next thing we need to do. So let's assign a target to the object. So when we create an object, we're going to say, this is your new target. So what we need to do is know who the player is. So we need a reference to the player. So var player, and we're going to, this is going to be, what we want is a reference to this script, the move to target script on the player. So we can say, so the player in this case is a copy of the move to target script. And if we come back to our targets object, it asks us for a player. We can now drag this player into there, and because this player has a move to target script, that will work. So now that doesn't, so we're still not doing anything with that. We now need to set the player's target. There's an easy way to do that. Player, because this script, the move to target script has a target variable, we can access that variable and say player.target equals the one that we've just created. So I'm going, and now hopefully create a target, move towards it. Create another target, create another target. And now every time we create a new target, it changes the value of target in that script, and it moves towards whatever the new thing is we create. So let me just go through that. That was a bit quick. So the move to target script has a variable, a property or a variable on it called target. Because that's a public property, we can access that property from other methods or from other scripts, as long as we have a variable which is an instance of that script. So what we have here is we created a variable called player, which was an instance of the move to target script. And in the inspector, we grab the player object, which has an instance of that script on it, and we drag that into there. We drag the player. We drag the player into there, and therefore this variable is now a reference to the move to target script that's on the player. And so when we when later on we get the target, look at the target property on that variable, if we set this value, we're now setting the value on the target script on the player. So then the target script on the player, which is happily sitting there waiting for us to give it a target, it keeps running this update script. As long as there's no target, as long as the target is null, it does nothing. But as soon as the target is set by the other script, it starts moving towards that target. So we've got communication between the two scripts. One script is creating targets and sending them to the other script, and the other script is as soon as it receives a target, it starts moving towards that target. It's generally considered kind of bad form or bad style to directly access the variables on another method, on another object, on another script. A better way to do this is for us to add a function to do it. So what we can do here is say function add target, and we're going to need this later, so we'll do it here. Right. So now this is a very simple function. All it does is it takes in as its input a variable t, and it sets the current target equal to t. So it's assumed that the caller is going to pass it another object, and it's going to make that object its target. Later on, we'll actually make this add target a little bit more sophisticated to handle multiple targets at the same time. But now what we can do is we can change this code here. So we no longer say that. Instead, in the same way as we can access variables on another object, we can access on another script. We can access methods on another script, and we just call it like we call any method. We call the add target method on our player, and it sets that target. So this is a nice way to establish communication between the two. It's a bit needed this way because it doesn't. So we normally let a script handle its variables essentially, and we don't like other scripts messing with our variables. It's called information hiding. The idea is that every script is responsible for its own variables, and if another script wants to change them, it calls a method to ask the other script to change its variables, rather than getting its hands dirty messing with the other script's variables directly. It's usually a good idea. In this case, it doesn't really matter. The code's probably equally as neat, but as we'll develop this, it'll actually get a little bit more sophisticated. This add target method will get more complicated, and it'll make sense using a method here rather than directly accessing across the scripts. Okay, so that does what we want. Well, it does. So it's a starting point. We're adding targets to the screen, and our objects moving towards the targets. But it would be nice to actually go around them in order rather than one by one like that, or rather than just jumping between them. What we might also do here is destroy the object when we hit it. So let's put some code in for that. We'll just do a really simple thresholding on the distance. So if the distance to the object is less than that. So let's say we have the distance to the object, that's v. So if v dot magnitude is less than the threshold, actually let's say if it's greater than the threshold, then we'll do what we were doing before. So if we're far enough away that it's then we'll keep going. But if it hits the threshold, then we'll destroy the object. So we'll destroy the target. And because we've destroyed our target, we have to set that target variable. We have to set that target variable back to null to indicate that we're not trying to track anything. If we destroyed the target and continued to try to track it, errors would occur because we'd be tracking an object which no longer exists. So what we're going to do is set target back to null. Now every time we hit something, we eliminate our target, and we're sitting there waiting for a new target again. So target is back to null, and as long as target is null, we don't do anything. So that's, let's even comment that. Let's put a comment in here. Do nothing. There we go. So, and this bit of code is move towards target, and this bit of code is destroy it. Wahahaha. Okay, so this is fine if we only want to track one target at a time, but what I'm trying to do is track multiple targets in order. So what we need to do is, rather than just storing one target that we're interested in, we need to store many targets. And when we need to store many copies of a thing, we use an array, right? An array is a typical way of doing this. So what we'll do instead of having a single target is that I'll turn this target into an array of targets, and we'll call it targets, plural. Right. So now when we add so what we'll do is take the array target. So we'll create, let me just think before I speak. This is what I want to do. So what I'm going to do is have this array of targets. Its size will be set by whatever we set in the inspector, but say we'll have 10 targets, and so we can have up to 10 of them. We'll take the first one off the array every time, and we'll track towards the first one in the array. When we've reached the first one in the array, we'll destroy it and we'll promote everybody. So the remaining ones will be shuffled up the array. So what we've done, we've got our target. It's going to be the first one in the array. If there's nothing in the array, then that target is going to be null. But otherwise, we destroy it. And now what we need to do is promote all the rest. So let me draw this on the board. We're going to have, it's going to be 5 targets, right? 0, 1, 2, 3, 4. Initially, all of these are going to be null. And when they're all null, well, we don't worry about whether they're all null, but as long as the number 0 is the one that we're currently tracking. And if the number 0 is null, then we have nothing to do, which is what I've said here already. The target is the one that we're currently tracking is number 0. If it's null, we don't do anything. Now, if it isn't null, we move towards it in the same way as we were doing before. But when we reach the target, we need to destroy it. So we need to, let me say that there's some target in there. We need to destroy that one. Now if we had, so if we had T1, T2, T3 like that, then if we reach target 1, we're going to destroy it, but what we're going to do is promote the other ones underneath. So we take T2 and copy it into there. We take T3 and we copy it into there, turn that into T3. And then we copy this null into there. And we might as well copy that null into there. It doesn't harm us to do that. We could make our code stop there. And then the last thing we do is that we'll actually set that one to be null. So that if we had, let me show you this in, start again. 1, 2, 3, 4. If we actually had this full of targets, so we had 5 targets in our list, in our array, sorry. And we destroy the first one, what we're going to do is then copy that one into there, and then copy that one into there, so that becomes T3, then copy up that way, so that becomes T4, copy that one up, becomes T5, and then we want to get rid of this because we won't want to have T5 hanging around in there, so we'll set that one to null. And if you watch, as we keep doing this, we keep filling the arrays with nulls until we've destroyed all 5 targets. All the array is null, and when all the array is null, we know the top thing's null, and so we don't do anything anymore. So this is nice. We can actually keep track of 5 targets as we go, and we can promote them as we do it. So I'll show you what that looks like in code. And this is going to be the last thing before we end. So it's easy. We say use a for loop for I equals 0. It's actually I equals 1. So we'll start at position 1. I is less than targets dot length I++, and we're going to copy target I minus 1 equals, not target, targets and then finally targets dot length minus 1, so that the last element is equal to null. Okay, so let me zoom in on that so you can see. So, there we go. So that's the code for what I just said. We start at position 1 and we copy position 1 into position 0. So if I is initially 1, we take position I minus 1, which is 0, and we set the value of target 0 to be the value of target 1. So that copies up one step there. Then we go on, then we set I to 2, and we copy 2 into 1. Then we go set I to 3, and we copy 3 into 2. Then we set I to 4, and copy 4 into 3. And then we've reached the end of the list. And so I is equal to targets.length, which is 5. And so we don't do anything more. But the last thing we do is take the last element, which is the length minus 1, and set that to null. So now we're, as we destroy things, we're taking them off our list of targets. Now, we've got 1 minute left, so the last thing we need to do is as we add targets, we've actually got to add targets to the list. When we add a new target, we're going to look at this list and say, okay, we're going to put a new target at this earliest available empty space in our target list. So we're going to search down the list until we find a null space, and we're going to stick the new target into that null space. So in this case, we go 1, 2, 3, 4, or 0, 1, 2, 3, 4. 4 is the only place we have a null, and so we'll stick our new target in there. If the list is full, we're just going to ignore the target for the time being. So do the same thing. It looks very similar to the code that we actually wrote the other day for ranking our high scores. We start with 0. We make sure the rank is less than the length of the list, so it's less than targets.length. Sorry, that's rank plus plus because we're using rank. Okay. Now, so this is going to this is looking at each element in turn from 0, 1, 2, 3, 4. Now the thing we need to do is say if the targets at that position is empty. So if there's a null, look for a null. If there is a null, we're going to do that. We're going to break, which I showed you in the last lecture as a way of breaking out of the loop without doing everything. So if there's 5 things, it's going to 0, 1, 2, 3, 4. When it gets to the 4th one, that one is equal to null, and so it'll break, and rank will be equal to 4 when we break. If, however, on the other hand, if there aren't any here, if all of these are null, then it'll go 0, 1, 1. As soon as we're at 1, that one will be null, and so it'll break immediately, and rank will still be 1. So the nice thing about this loop is that it'll stop at the appropriate point, and the value that is in rank at that point will be the place we want to put the thing. So we can say as long as the rank is less than the length of the list, because if it could be that the whole list is full, in which case there's nowhere to put it. But as long as the rank is less than the length of the list, in which case we've found an empty spot, then we'll put the target. So we'll take that spot and we'll assign it the target that we've just picked up. Okay. So now let's look at that. Let's come over here. Here's our player. We've got an error in our code. Oh, good grief. What have I done? Rank 0, that looks right to me. Oh, I keep using int where I mean var. Sorry, that's holdover from a different programming language. Unknown target. That should be targets. Yeah, okay, code. No syntax errors. Okay, so initially this list is of size 0. We don't want that. We want to say 5 targets. Now, okay, so if I click around, it puts the targets onto the list and removes them one by one. If you watch over the right-hand side, which you probably can't see very well, but if you go and watch the video, as I add targets to the world, that target list fills up. As I remove them, as it removes them, the target list gets unfilled, and it fills up with nones again until the whole list is none, in which case it stops doing anything. Now, if I add more than 5, the later ones get ignored because there's no space in the list to put them, and so it'll delete the first 5. It'll kill the first 5, and then just stop, because those two that remained, there wasn't any space to put them in the array. So we ran out of time. What I'm going to show you next lecture is how to use a variable length array so that we can record as many targets as we want. So that can wait till next time. See you all later.